Linear equations. Solution of an equation is the value of the variable that makes the equation true. To find that solution, you need to get the variable alone on one side of the equal sign. And the inverse operations are operations that undo one another. So to get the variable on one side of the equal sign, we will have to use the inverse operations. So the inverse operation, in this case, when we have an addition, to undo addition, you'll use subtraction. So you'll see an addition sign, you'll see a subtraction sign. So the inverse operation would be subtraction. And then with subtraction, you'll have addition is the inverse operation. So you'll actually see the addition and subtraction signs to be able to do the opposite. Now with multiplication, the inverse operation is division, but we won't see a multiplication symbol. What we're going to see is a number attached to a variable. And when we have a number attached to a variable, in algebra, what that means is we're multiplying that number to the variable. So when you see this, the inverse operation would be division. And then if you have division, the inverse operation would be multiplication. And the way that we see division in algebra is with the bar over a variable over a number. And that bar means that we're dividing. 8's being divided into x. So the inverse operation in this case would be multiplication. So when you see the bar, it represents division. So we're going to start with examples of one-step equations. So here I need to isolate x on the left-hand side, and with x I have a negative 10. Well, the inverse operation of a negative is a positive, so in this case to solve, I'm going to need to add 10 to both sides. So when you do that, that's going to cancel out that negative 10 and positive 10 equals 0, and I'm left with x by itself equals, and then I do the arithmetic here. A negative 4 plus 10 equals 6. So my x value is 6. And I could always take that x and substitute it into the original equation and see if it's true. This next example is a one-step equation. I have x plus 8. I want to get x by itself. I need to do the inverse of plus, which would be subtraction. And what you do to one side of the equal sign, you have to do to the other. So I end up getting my x equals, and then in this case, be careful. We have same sign. A negative 2 minus 8 equals a negative 10. Same sign, add and keep the sign. So now you see this example where we have x with that bar over a negative 4. Remember, that bar equals division, and the inverse of division is multiplication. So I'm dividing a negative 4 into x. I want to get rid of that division, so I need to multiply both sides by that negative 4. That will cancel out that division. And then I have to do the multiplication of a negative 11 times a negative 4 will give me a positive 44. This next example is a number attached to a variable, and when a number is attached to a variable, it's multiplication, and the inverse operation would be division. And I like to represent division the same way you'll see it in an equation with the bar. And that will cancel out that 5 and give me a coefficient of 1 in front of x. And that's what we need. And then I do the division of 35 divided by 5 would give me 7. So x equals 7 in this case. This next example, we have a negative attached to a variable. So when you have a negative attached to a variable, you're not done. You have to continue until the variable has a coefficient of a positive 1. And again, we don't see the coefficient of positive 1, but it has to be positive. So when I have a negative in front, that means I have a negative 1, and the inverse operation of multiplication would be division. So I would divide both sides by a negative 1 and get my solution, x equals a negative 19. You could just do the opposite of what it equals, and that would also be correct. So notice here my variables on the right hand side. So sometimes your variables won't be on the left hand side. They might be on the right hand side, and you have to isolate the variable. So now what is attached to the variable is a fraction. And whenever I want to get the fraction to be equal to a coefficient of 1 of the variable, I need to multiply by the reciprocal. When I multiply by a reciprocal, I get 1. So to remove a fraction that's attached to the variable when solving an equation, multiply by its reciprocal. And notice I have a negative, so I'm going to have to multiply by the reciprocal and the negative. That will cancel out and give me a coefficient of 1. And then on the other side, I have multiplication of fractions. And when you multiply fractions, you want to simplify first, and then you're going to multiply across. So in this case, I get x equals a negative 3 over 10. Pause and try. So this is a positive 16. I'm going to subtract 16, and I'm going to get x equals a negative 12. Pause and try. I have to add 3 to both sides, and I end up getting x equals 0. Pause and try. Again, when a number is attached, it's multiplication. The inverse operation would be division. I end up getting x equals a negative 6. Pause and try. That bar represents division. The inverse operation is multiplication. I multiply both sides by 5. I get x equals a negative 10. Pause and try. To solve for x, I need to multiply by the reciprocal to get the coefficient of 1. And it has a negative, so I'm multiplying both sides by a negative 6 over 5. That's going to cancel out, give me that coefficient of 1. And then I need to multiply fractions by simplifying first and then multiplying across. So the solution here, x will equal a negative 4 over 5. Now when we're working with two-step equations, the first thing you want to do is get rid of the plus or minus. So you want to do the inverse operation if you have a plus or minus first. And then you'll do with what's attached to the variable. So deal with the addition or subtraction first, and then do what's attached. So in this example, 8x plus 5 equals 61. I'm not going to worry about what's attached to the variable. I'm going to get rid of the plus 5 first. So I have to do the inverse of plus, which is subtraction, and make sure you do it to both sides of the equal sign. So I'm subtracting 5 from both sides. I'm going to be left with 8x equals 56. Now I can deal with what's attached to the variable. And again, it's a one-step equation. I have 8 attached. It's the opposite would be division. I divide through by 8, and I get my solution, x equals 7. So I'm still working with the two-step equation, except for my expression or my variable that I need to solve for is on the right-hand side. I still work the same process. I want to get rid of the plus or minus first, and I have a plus 10, so I need to subtract it from both sides. So I end up getting 8 equals 4a. So now you have the 4a, you want to get rid of that 4, so you're going to need to divide because it's multiplication and the inverse is division. So whatever you do to one side, you have to do to the other. So be careful here when the variable's on the right-hand side. Just be careful that when you do your division here, you're dividing by the number that's attached to the variable, not what it equals. So we end up getting a equals 2. This next example, things are just mixed up. I have a negative 4 plus 7x equals 3. I want to first get rid of that negative 4. And the inverse of a negative is a positive or plus. So I'm going to add 4 to both sides, and then I'm going to end up with 7x equals 7. Now I'm going to divide through by 7, and I get my solution for x equals 1. Now this next example, be careful because I want to get rid of the positive 15 first. That minus is to the 2x. So when I solve for this, that minus will be attached to the 2. So be careful. So the first thing we're going to do is move that 15 over to the other side of the equal sign. And because it's positive, I'm going to subtract. So I subtract 15 from both sides. Now be careful, because what's left here is that minus 2x, which means it's a negative 2x that I'm going to be left with. So now I have a negative 2 attached to x, and the inverse operation here would be division, and I need to divide through by the negative 2, and I get my solution here, x will equal 2. Pause and try. Two-step equation, I'm going to subtract 5 first, and then I'll deal with what's attached. I divide through by 7, I get my k value equals 5. Pause and try. So the first step here, be careful, you have to subtract that 8. And now you have same sign, add and keep the sign. So I end up getting a negative 99 equals 9x. And now you need to divide. You're going to divide through by 9, and you get your solution here, x equals a negative 11. Pause and try. So you want to first move that 6 over. You're going to add 6, and then you're going to be left with 12t equals 36. Divide through by 12, and you get your solution, t equals 3. Pause and try. So the first thing you need to do here is subtract that 11. That negative 3 comes down with the x. It's negative 3x equals a negative 6. You're going to divide through by a negative 3, and you're going to get your solution for x. X equals 2. Pause and try. So the first thing you need to do is get rid of that positive 4. We're trying to solve for x. It's positive 4, the inverse is a negative. Minus 4 from both sides. Now keep in mind that minus sign gets attached to the 3, so it's now a negative 3x. And now you divide through by a negative 3, and you end up with your solution for x equals a negative 7. So now this is still a two-step equation, and two-step equations you have to undo the addition and subtraction first. So don't worry about this x over 3. Don't let that throw you off. Once you subtract 2 from both sides, you'll see that what you're left with is division. So 3 is divided into x, and the inverse of division is multiplication. So don't make these problems harder than they are. Multiply both sides by 3, and you get your solution for x equals 18. Two-step equation where division's attached to the variable. And this next one, we have a fraction attached to a variable, but it's still a two-step equation. And two-step equations work with the addition or subtraction first. So in this case, I want to add 9 to both sides. Now just be careful with your arithmetic. A negative, different signs mean you subtract and keep the sign of the higher number. That's where the negative 20 is coming from. Now we have a one-step equation where I have a fraction attached to the variable. Whenever you have a fraction attached to the variable, multiply by the reciprocal. Multiply by the reciprocal, which is 7 over 5, and then you have an integer being multiplied to a fraction, so remember to put that integer over 1. When you put that integer over 1, then you have the fraction times a fraction, and then you can simplify and multiply across. One key note here is notice that I emphasize that negative, because when you're dealing with fractions and you're multiplying, you might forget that you need the negative sign and get the wrong answer. So I'm going to simplify here. I end up getting a negative 4 times 7, which is going to give me that negative 28. So x equals a negative 28. Pause and try. You're going to add 1 first. Then you're going to multiply both by 7, and you get your solution here, x equals a negative 28. Pause and try. You're going to add 6 to both sides, then you're going to multiply by the reciprocal. Put that 15 over 1, simplify, and multiply across. So you end up getting x equals 20. So now when we're working with multiple steps in an equation, you want to follow this stepping process. So the first thing is if you have an equation that has parentheses in it, you need to do the distributive property first. So remember, when you have the distributive property, you're going to have a number attached to an expression, and you're going to have to take that number and multiply it to everything inside the parentheses. That's how you remove the parentheses. And then the next step is to combine like terms. And like terms will be on the same side of the equal sign. And that means that when you combine, you're going to add or subtract the coefficients, or you're going to add or subtract the constants. So if you see like terms, you want to get it together before you do any movement in the equation. So make sure you're cleaning it up. I always call combining like terms cleaning it up. And then the next step is to get variables on one side of the equal sign. So in multi-step equations, you might have variables on opposite sides of the equal sign, and you're trying to solve for the variable. Well, you can't solve when you have multiple variables. So you want to get them to just one side. And to do that, when you move, you always have to do the opposite. So if you're moving from one side to the equal sign to the other, you're doing the opposite of what the sign is. Then at this point, you'll have a one or two-step equation. So once you get to the two-step equation, you'll know what to do. You're going to undo the addition or subtraction first, and then you'll deal with what's attached, whether it's multiplication or division. So the multi-steps, do the distributive property first, clean it up by doing the combined like terms, and then you'll start moving. Get the variables to one side of the equal sign, then you'll have that two-step. Get rid of the plus or minus, and then deal with the multiplication or division. So this first example here of a multi-step equation is I have multiple variables, but the multiple variables are on the same side of the equal sign. And because they're on the same side of the equal sign, you're simply just going to combine like terms. And when you combine like terms, you're going to add or subtract the coefficients. So in this case, I have a plus 2x and a minus 7x. So when I combine here, I'm going to end up having 2 minus 7, which gives me a negative 5x. And then I'm just going to bring down the plus 3 equals 8. Now you see, I have a two-step equation. I'm going to subtract that 3, and then I'm going to divide through by that negative 5. And I get my solution here, x equals a negative 1. Pause and try. So you see here I kind of switched it up, making you think a little bit. The variable's on the right hand side, but I have combined like terms. I have to combine that first. I'm going to end up having a negative 3 minus 7, same sign, add and keep the sign. So I'm going to end up with a negative 10x, and everything else is just coming down. And now I have the two-step equation. I need to move that positive 6. To move that positive 6, I'm going to subtract 6. So I'm going to be left with 30 equals that negative 10x. That minus sign is with the 10x. So now I have to divide through by a negative 10, and I get my solution here, x equals a negative 3. This next multi-step equation has distributive property. It has parentheses. In order to solve, I need to do the distributive property. So the first thing you're going to do is take that 3 and multiply it to everything in the parentheses. Always double check your arithmetic when you have the distributive property. 3 times 2 is 6. 3 times 6 is 18. I multiply correctly, and now I have that two-step equation. So I'm going to add the 18 first, and I'm going to end up with 6x equals 12, and now I'll do that division, and I end up with my solution for x is 2. This next one I'm showing because you want to be very careful when you have the distributive property and it's a negative number. So in this case, I have a negative 2 that I need to multiply to everything in the parentheses. So when I do this distributive property, double check your arithmetic. A negative times a positive is going to be a negative. So I get a negative 6. And then a negative times a negative will give me a positive. So I'm going to end up with a positive 2x equals 4. And now I have that two-step equation. I'm going to add 6 to both sides, and then I'm going to divide through by 2, and I get my solution, x equals 5. Pause and try. So in this case, you're distributing a negative. You end up with a negative 15x plus 5. And now you want to move that plus 5 over by subtracting. And then you want to divide through by that negative 15. And your solution here, x equals a negative 2. So this next example, we have the distributive property and multiple variables. So the first thing in a multi-step equation is do the distributive property. So you want to first remove the parentheses before you start doing anything else. So I do the distributive property here. Always double check your arithmetic. 4 times x is 4. 4 times 2 is 8. So I end up with 4x minus 8 plus 2x equals 40. Now, I don't want to start moving yet because I have a little bit of a mess, so I want to do that combined like terms first. And they're like terms because they're on the same side of the equal sign. So I'm simply going to add or subtract the coefficients. So I have 4x plus 2x will give me 6x minus 8 equals 40. Now I have that two-step equation. And again, two-step, get rid of the plus or minus. I'm adding 8 first. And then I'm going to divide through by 6. And I get my solution, x equals 8. Pause and try. I do the distributive property here, and then I'm going to combine like terms. Again, always double check your arithmetic for the distributive property. I combine like terms. I get 2x minus 5 equals a negative 3. And then I get that two-stepper. I'm adding 5, and then I'm going to divide through by 2. I get my solution, x equals 1. So now this next example, notice here that I have variables on opposite sides of the equal sign. We can't just simply combine them. When they're on opposite sides of the equal sign, you have to move them. And in order to move, you have to do the opposite. So it doesn't matter which direction you choose to move in. You can move the 2x over to the 3x. I can move the minus 3x over to the 2x. But you have to move it by doing the opposite. So in this case, I chose to move the negative 3x over to the 2x, and because it's minus 3x, I have to do the opposite, which would be plus 3x. So I'm getting the variables to one side of the equal sign. I'm doing the opposite. I get 5x minus 2 equals 3. Now I have a two-step equation. So I'm going to do that addition, and then I'm going to deal with the division. So in this case, I end up getting my solution here, x equals 1. Pause and try. So some of you might have moved in a different direction. I chose to move the 6x over by adding 6x to both sides. Be careful here though, that is a negative 2x plus 6x, so you're going to end up getting 4x when you do that arithmetic. Now it's a two-step equation. I subtract 11 from both sides. I get 4x equals a negative 4. Divide through by 4. You get your solution, x equals a negative 1. So now this next example, I have distributive property, plus I have variables on both sides of the equal sign. So again, distributive property is first. You have to do the distributive property when there's parentheses in an equation. So I'm going to take that number, I'm going to multiply it to everything inside the parentheses, and I'm going to end up with 24 minus 4x equals 8. Always double check your arithmetic. Now, one thing I want you to notice here is that 8x is already by itself on one side of the equal sign. So I already have x on one side by itself. So when you're doing the movement here, you don't want to take the 8x and move it over to the negative 4x, because if you do that, you'll end up with nothing on the one side of the equal sign. Or if you know, you put 0. But I always move to the side that the variable's already by itself. So I would take that 4x and move it over to the 8x. I would add 4x to the 8x, and I would get 24 equals 12x, and now it's a one step. I divide through by 12, and I get my solution, x equals 2. So when the variable's already on one side by itself, take the other variable and move it to that side by doing the inverse operation. Pause and try. You do the distributive property, double check your arithmetic, And then I'm going to move that 6x over to the 9x because 9x is already by itself. So I end up getting a negative 9x equals 3x, and then I'm going to divide through by 3, and I get x equals a negative 3. Pause and try. Doing that distributive property, always double check that arithmetic, and now we need to get the variables together. And in this case, it doesn't matter which direction you choose to move in because there are things with both variables. So I chose to move the 3x over, and I get 14 minus 4x equals 26. Subtract 14, and then divide through by a negative 4, and my solution here is x equals a negative 3.